Welcome to Under the Microscope. This series is brought to you by the Real Scientists Nano team. Our goal is to provide a platform where scientists can communicate their work and interact with the public. With that in mind, every week we introduce you to a scientist working in the field of materials and nanoscience, who would be curating the RealSci_Nano Twitter account. Hi everyone, today we have with us Candice Majewski, who is an academic in the Department of Mechanical Engineering at the University of Sheffield in the UK. Hi Candice, really nice to have you on Real Scientist Nano.
Hi, thank you very much for having me.
Wonderful. Let's start by understanding your career journey so far. So how did you end up in your current research field?
Well, to be honest, the most honest answer I can give you is I ended up in my research field completely by accident. So I had no real clear idea of what I wanted to do for quite a long time, other than probably some form of engineering might be kind of nice. And so it was only during the very first, I think probably the last couple of months of my engineering degree, which was at Loughborough University, we had a guest lecture about 3D printing, and at the time that was mainly known as rapid prototyping, so it was quite a while ago now.
Right.
And I guess it just clicked, and it was the first time that I'd seen something that I was more than just passingly interested in. So there were lots of things I thought could be interesting as a job, and then I saw this and I was like, wow, that's absolutely the thing that I was meant to be doing. And so it was just, there were so many possibilities for what you could use it for, so many ways in which you could look to improve it as well, because it was still quite early on. So it was kind of exciting to think about getting involved in that. And so had that. I was lucky enough that there was a master's course starting up in that area just literally as I was finishing my degree. So I was able to do that, and everything kind of just spiraled from there. But yeah, that first introduction to it was just purely by accident. We had this guest lecture and then everything followed on from that.
Oh, that is so nice. It's really, really, really cool. So if you could explain to us, how does your current research fall in this big picture of materials or nanoscience? Where does it fit in this big puzzle?
Well, so a lot of what we do, so myself and my team, we look at the way materials behave in our 3D printing processes. And then on top of that, how do the parts that we make in those processes, how do they behave in the longer term? And it's genuinely never as simple as you pop a material in the machine and you just make really good quality parts, right? You try things, you try modifying the processes, you try modifying the materials, and eventually you get to something good. So my very specific area of interest is in powdered polymer 3D printing processes. And we need to understand, basically everything about the materials. So things from the very physical size and shape of the materials, and we know that makes a difference, through to their thermal characteristics, their chemical characteristics, the microstructure and the properties of the parts that we make. And what you really understand is that the materials themselves and the way they interact, if you can understand those things, you can start to make better parts or products at the end of it. We're also starting to look at how properties of materials or of our materials change over time. So we have a decent understanding of what happens at the beginning when we take a part out of the machine. We don't have such a good idea of what happens later on. So, in a year's time, how will that part be behaving?
Right.
So really for us, it's figuring out how one thing influences everything else and what those material characteristics do to the quality of what you put out of the process.
All right. Yeah, that's quite, I at the risk of repeating myself, it does sound really interesting, because I never thought about it from the 3D printing perspective, that the properties actually affect how they behave later on. So it sounds to me that you are involved with a lot of innovative and interesting research projects. and experiments as well. But if you have to pick one research project that you're most proud of, or most fun, or a quirky one, I know it's difficult. If you have to pick one, could you pick one for us and explain it to us in simple words in the section we call In Other Words?
I'm going to pick one because you've asked me to. I find this so difficult because before coming onto this podcast, I was thinking, oh, but actually this one's cool because of that, and this is cool because of this. But I've been good and I've picked just one. And so this is to do with some work we did looking at bringing antibacterial properties into 3D printed parts. And it kind of comes from a perspective of saying we can make parts, that's very good, but can we get them to work harder for us? So can they do something more than just sit there and be an object?
Right.
And so why I've picked that was actually, it was really interesting to bring together a team of researchers with 3D printing experience, but also the microbiology experience. And so I think you learn a lot from working with different people in different disciplines.
Right.
And trying to understand, even when we were writing a paper on it, it was very different ways in which we would naturally write things. So it was interesting from that perspective. And what we basically did, we took a silver-based material that we know helps to kill bacteria. We mixed it in with some of our more standard 3D printing materials and then made some parts out of it. And the reason I've picked it, apart from the fact that it brought together so many different people, was actually what was really interesting for us was it worked really well in some cases and it didn't work really well in others. And I think for me personally, the research is always more interesting when you find something more to explore. So if it didn't work at all, we'd have been very sad. If it worked perfectly for everything, it's kind of, well, there you go, we're done. Yeah. And so actually finding that there's more to explore and get into those details of it, I think is what, certainly for me, is what makes research really interesting.
Okay, all right. Yeah, I can understand why you picked this project as the one that you're most proud of. Let's say more fun one, or one of the most proud of. Let's say that. Let's not just say it. To be fair. All right. Let's move a bit away from our research and towards the other parts of an academic's life, which is teaching. So, do you teach any courses? And if you do, would you like to mention any?
Yeah, so actually, back when I was at Loughborough, which was where I also did my PhD, so it took me quite a while to leave Loughborough, let's say. I was able to do quite a bit of teaching there, basically because I found it fun and interesting. And what I learned at the time was if someone comes and asks you as an academic, hey, could I do some teaching? Most people are very happy to kind of support that. What was nice when I started as an academic in Sheffield was I got to actually think about designing a module from scratch. And so with another colleague, we designed 2 modules on 3D printing that were interlinked but separate. And actually just being able to really think about what's the message that I want to get across in this, what do I want the students to pick up from, you know, how can we do that in a way? So we have lots of discussion sessions in these type of modules, lots of opinion-based things. So saying it's not just, I don't just want you to learn, if I write this down, it's the correct answer, but, you know, form your own thoughts on things. So actually being able to design that from scratch and then to keep developing it is a really fun part of the job. I don't think you ever get to the point where a module or a course is perfect. I think there's always something you can add to it or you can do. And then alongside that, we also have an additive manufacturing stream of one of our master's programs, which has some of the core content from our mechanical engineering master's programs, but also with a big portion of additive manufacturing or 3D printing in it. And that's quite nice too, because it gives people a chance to specialize a little bit and get a bit more of an in-depth knowledge of it.
Okay, all right, that sounds good. It's really interesting. This world of printing is completely new for me. So every course that you mentioned is like, yeah, if I were to go back and study, do my bachelor's, master's, or even PhD as well, I would definitely like to take these courses of additive manufacturing, especially the ones where it's more of a discussion of sorts. And not just that like a one-way street, it's more of a multi-way street where everyone's talking and contributing. So this is really interesting.
You learn more that way, I genuinely believe. I think if I stand up in front of you for, 20 lectures over 10 weeks or whatever, and I just tell you stuff, You can find it interesting and you can relate to it, but actually if you're having to really think about it, and so I might ask a question like, which do you think is the best 3D printing process? And there's clearly no right answer in that. There's lots of arguments to be made for and against different processes, but actually just by asking the question in that way, you have to think about your understanding of all the different processes and then put it together and think, well, what do I think are the most important bits of it? And so, and actually our students are all great and they all really respond to that and they all really get involved in the discussions. And I think every year I hear something that I've not heard before.
Oh, nice.
Not from me. And then I write it down and I make a note to mention, last year one of your colleagues said this. But yes, it's fun from my perspective as well as from theirs, I think.
Okay, all right. Yeah, I really like your approach. It's really, really interesting to keep it more interactive, also for students, because they should have fun while studying and while learning new things, right?
Absolutely.
Yeah, that sounds really interesting. Now let's move towards the research, back to the research experience, away from teaching. I hope your experience so far has been wonderful and will continue to be wonderful. However, if you had 3 wishes to improve your research experience, what would you ask for? And I'm not promising anything here, okay?
I'm taking it as a promise.
Okay.
So I thought, there's loads of things I think that would make small improvements. I think I have to say the number one thing would be just for the research landscape to be fairer, more equitable, for everyone to have a good shot at getting a position in the first place and getting into science or engineering, but I think also to then have a good experience once they're in there, because it's not enough to say, hey, we've now fixed the barriers that were stopping certain people or certain groups of people from getting into this area. You have to then do something about it at the stage where they're actually in the job. So, and to be fair, I think I've been very lucky in not having many of those bad experiences that a lot of people have. But I think it still has to be the number one thing is everyone gets a fair shot, everyone gets a good experience when they're there. The second thing, which ties in a little bit to that, I'd love to see more long-term funding for researchers, because I think they're in such precarious positions a lot of the time, and it's kind of this constant, now I'm coming up to the end of my contract, so I'm looking for the next contract and the next contract. And actually, if you had a situation where people could be employed as a researcher in a team or a group or a department, and then perhaps work on multiple projects as time goes on, I think that would help a lot in terms of the researchers themselves. And if I'm honest, as an academic, it would help because a lot of times, what's happening with my team and the people who are working in my team, that's kind of the thing that keeps you awake at night sometimes as an academic too. So I think if we could fix that and we could let researchers have that security, that ability to learn and keep practicing their skills, it would benefit everyone, I think, in that way. And then this is genuinely, I think, my third wish, is I just want there to be enough questions that we still need to answer to keep me going until I can think about retiring. So if we've solved everything, like if everything's fixed by the time I retire, great. If not, great, because there's loads of things for the future researchers to be working on. To be fair, I don't think we're going to run out of those questions anytime before I retire, but that's kind of my goal, is I want there to be enough research to keep going on with until it's time to retire and take things a bit easier.
That's really, especially your third wish. It's so out of the box. I never thought about it. I really honestly never thought about it, that having enough interesting questions that are unanswered to keep the research more fun or more juicy, so to say. Oh, wait, this is an interesting question. Let me try to crack that. That is really interesting. And also your first and the second wishes. The first one, definitely, as a woman who is from India, I completely like it's like yes. And also the second one with the long-term funding, I think it's really, really important for researchers not to just run around, run behind like research grants and 3 years and maybe 5 years or even 10 years sometimes, but
having more long term, so you can focus actually on research and teaching and actually doing the job rather than making sure you have the job.
Exactly. Well, and I think the other part of that is that a lot of times, because there's so few funding schemes for researchers to apply for, it's even worse because you're reliant on someone else to do it. So you're reliant on your PI or your academic to be bringing in funding. So if I'm just bad at getting funding, or if I'm good at getting funding but I've not got time to be applying for the funding, or something's happened personally or whatever, you're reliant on that person as your PI to be getting the funding. So it's even more out of your hands. And we have some of these schemes that people can apply to, and, you know, certain fellowships, which are great, but definitely not enough of those to go round. And definitely too much emphasis on, you know, all of these things that we know put people off in a lot of cases. Like, we're looking for the best of the best and like the superstars of the future and all of this. And yeah, so I think there's too few of the funding streams that researchers can apply for individually. So then it's kind of a double-edged thing. It puts more emphasis on things that are out of your control, and I don't think that's ever a nice situation to be in.
Yeah, absolutely, absolutely. Well, I hope that we are working towards achieving all three of your wishes. I wish I could just grant them just by like, yes, all is gonna happen. But I would like to believe that we are working towards it positively, and it will happen in the near future. Speaking of future, what are you most looking forward to in the next 3 months?
So I'm going to give you two answers to that if I can. Work-wise, it's very simple. I'm sure it's what's on a lot of people's mind, is getting our experimental work back up again. And I don't think there's ever a good time for things to happen, and I think we were completely right that everything shut down as it did. But just before lockdown, we had so many things that were, I want to say, almost finished. So just need that last piece of work on this, and we just need to do some characterization in this lab, and there were lots of, we just need this thing. So actually getting those things finished off would be really good. I have a wonderful team of people in my lab, all of whom and I've had separate conversations with people, so everyone's kind of excited to get back to work as long as we can do it safely, and that's a key thing. And, you know, so I think as long as we can get back to that level of safety and protecting the people in the lab, which has to be the most important thing, then I think being able to get those bits of work done and kind of, you know, finally be able to talk about it and say, hey, we've done this, and here's what we found out, and here's the last missing bit that makes everything else make sense before. So that's the main thing work-wise. I'm going to say on a personal level, I was really, really excited for the new Fast and Furious movie, which was coming out really soon when we went on lockdown, and then got put off, I think, until next year now. And so at some point when it's safe to go to the cinema, albeit maybe a bit more socially distanced, or when it maybe comes out to, you know, be able to watch it at home or something, it's a really small thing, but it's a thing that I'm super excited for when we actually get to do it.
Yeah, it might seem like a small thing, but it symbolizes something quite big. I mean, who would have thought that we are waiting for the cinemas to open? We are waiting for movies to release. Who would have thought? Because this has never happened before. So yeah, it's completely. That's really an interesting thing to look forward to. Absolutely. Candice, before we let you go, we do want to understand from you what are the big challenges that the field of materials or nanoscience is facing at the moment? What are the big questions the researchers are working towards solving or addressing?
Well, so I think I'm going to pick one that's deliberately a little bit non-scientific, actually, because one of the things that I think we struggle with sometimes as a community, and this is probably true of whatever research community you fit into, is we're really bad still at explaining things simply. And so I really genuinely believe that learning how to explain things in a really easy to follow way, learning to accept that you can't give every piece of technical information in one sentence, and so figuring out what's enough information to give someone the point, I think, is really important. Because if you can if you can explain your research in a way that an expert in a completely unrelated area gets it, that's when the interesting conversations start. And I mentioned a bit with our antibacterial work that we'd talk about things, and for a minute we'd be talking about something completely different, and eventually you'd realize, oh, when you say that you mean this thing, and when I say that I mean this thing. We're also doing some work with our a couple of people in our statistics department, and it's the same thing. They use certain terminology very differently to how I might use it as an engineer. But I think if we can get past that sort of language barrier sometimes and just have really interesting conversations at a significant but not a too deeply technical level, I think that's when you start to say, do you know, that thing you've just said, that could be really relevant to this thing that we're doing or this problem that we haven't been able to solve. And so we'd find lots of new collaborations and lots of new ideas just by talking more sensibly.
Yeah, that makes sense. Communication, more clear and more of the communication, constructive communication.
Yeah, absolutely.
Yeah, that makes sense. That makes sense. Absolutely. Thank you, Candice. Thank you very much. As I said, your research is really, really interesting, and it has been lovely speaking with you. And we are looking forward to having you on Real Scientist Nano.
Thank you very much. It's been lovely talking to you as well.
Thank you for listening. To know more about us, please visit our website, realscientistsnano.org, and follow us on Twitter at realsci_nano.